Assalamu alaikum wa rahmatullahi wa barakatuhu, students. How are you all? I hope all of you will be fine. Friends, we were discussing word problems of chapter number 6. This is lecture number 2. Let's start. In the previous lecture, we discussed up to 6.7. Now I am going to discuss with you the rest of the numericals or word problems. So the 6.8 is given a 50 kilogram man moved 25 steps up in 20 seconds. Find his power if each step is 16 centimeter high. So mass is given 50 kg, t is 20 seconds, and power you have to find. First, we find the height of 25 steps. So 25 multiplied by 60 will give you 16 25 into 16 will give you 400 centimeters. So in order to convert centimeters into meters, you will divide with 100, you will get 4 meter. Now by using the formula of power is equal to work done over time. Work done is mgh because he is changing his position. That's why we have used here mgh. Work done is in shape of potential energy. So 15 to 10 into 4 will give you 2000 joule, and power is 2000 over 20 because power is equal to work done over time, so you'll divide 2000 with 20 and you'll get 100 watts. Coming to 6.9, calculate the power a pump which can lift 200 kg of water through a height of 6 meters in 10 seconds. So power you have to find. Mass is given 200 kg, height is 6 meters, and time is 10 seconds. So power is equal to work done over time. So work done is mgh, m is 1200, g is 10, and h is 6. So you will get 12,000 joule, and for power you will divide work done over time. So 12,000 over 10 will give you 1200 watts, which is power. Now 6.10, after this the last numerical is missed, sorry. In the next video I am going to explain that numerical. Now I am going to start review questions of chapter number 6. Review questions of chapter number 6. The first question is define work. What is its SI unit? Work is done when a force acting on a body displaces it in the direction of a force. You know the concept of work done in physics, that when you apply some force on a body and it covers some distance in the direction of force, so you can say that you can find the work by multiplying force with the displacement covered. So the SI unit of work is joule. Now 6.3 is when does a force do work? Explain. A force only does the work when it acts on a body and the body moves through some distance. The velocity of the body should not be uniform. Definitely the velocity should not be uniform. It must cover some distance in the direction of force. Sometimes it happens that you apply force and the body is not covering the distance in the direction of force, as in case of um, lifting a bucket, that you are going with a bucket, you are applying force, but according to the rules of physics there is no work done. Why? Because there is an angle of 90 degree between the direction of force you are applying and the displacement covering by displacement covered by the bucket. So in some cases it happens that the force is being applied, everything is there, but still the work done is zero because of some implementations of physics rules. 6.4 is why do we need energy? We need energy to perform all activities of life. Definitely, we take chemical energy in shape of food, and that chemical energy is converted into different forms of energy like heat, kinetic energy, and that's why we are able to fulfill all the activities of our life. So in daily life, we can come across a lot of examples in which one form of energy is converting into other forms of energy. Just in case of a car, you put petrol in the car, which is a chemical energy, and you can see that car moves. That same chemical energy is converted into kinetic energy. Examples like this, you can find a lot of examples around your surroundings. Define energy. Give two types of mechanical energy. The ability to do work is called energy, and two types of mechanical energy are kinetic energy and potential energy. Define kinetic energy and drive its relation. See long question number 1, you know very well. Long question number 1, in the answer of that question you will find the same question, and also you have done it in kinetic energy portion when you studied the chapter. At that time you derived the formula, and also you know very well what is kinetic energy. Define potential energy and drive its relation. Same is the case with this question. You have to see long question number 2. You can open your books and you can see the topic of potential energy from your book. It is there. The question is there. You can solve it, or you can learn it from your book. 6.8 is why fossil fuels are called non-renewable form of energy. Fossil fuels take millions of years for their formation, so they are called non-renewable form of energy. Non-renewable means that once they are finished, after that they'll take millions of years to be reproduced. So that's why they are called non-renewable, because you know very well fossil fuels are the dead plants and the dead bodies of animals which were buried under the earth millions of years ago, and then after that they are um, found in shape of petrol and shape of gas underneath earth, and it takes millions of years for them to be reproduced. So that's why they are called non-renewable. They cannot be reversed easily. 6.9, which form of energy is most preferred and why? Solar energy is the most preferable because it is very cheaper and does not cause any type of pollution or any other environmental problem. You know very well nowadays in a lot of countries solar energy is being converted into electrical energy, and the needs of the population they are being met. So you can say after 10 years it will become very cheap, and it is basic source. So main, I think the one of the most important benefits is that it does not pollute the environment. Next is 6.10, how is energy converted from one form to another? Explain. You can see question number 4. You have studied a lot of types from your same chapter number 6. 6.11, name the 5 devices that convert electrical energy into mechanical. Electric fan, it is taking electricity and converting it into mechanical because it's a machine. Same is the case with electric motor, electric toys, floor mills, and vacuum cleaners. These are the 5 types of machines which take electrical energy and convert it into mechanical. 6.12 is name a device that converts mechanical energy into electrical energy. Wind machines, hydropower generator, dynamo, and a thermal power plant. All these machines, they take mechanical energy and convert it into electrical energy. Just in a case of generator, you know, you put chemical energy inside it in shape of petrol, and or you can also run it with the help of gas, but it is converted into electrical energy. It generates electricity. Same is the case with the rest of the 4 machines. 6.13, what is meant by the efficiency of a system? The ratio between the output and input of a system is called efficiency of that. Output means that the work done by machine, and input the work you have done on the machine. Both of them, they are work done, but there is a little bit difference. So when you will divide the output, the work done by the machine, with the input, which is basically the work done by you will get efficiency. Just in case of a motorcycle engine, the efficiency of a motorcycle engine is 45 to 55%, because most of the energy is lost in shape of sound and heat. 6.14, how can you find the efficiency of a system? Efficiency of a system is found by dividing the work done by the system, by the work done on the system, and then multiply it with 100. Percentage efficiency, you will just multiply the efficiency formula with 100 and you get percent efficiency. Efficiency basically tells us about how much the machine is efficient. For any machine, we can compare its efficiency by dividing output with input. What is meant by the term power? The rate of doing work is called power. As you know, in mathematics, whenever we divide something with time, we need to know that with time how is it changing. So that's why work done, power is basically rate of doing work. Define watt. If 1 joule work is done in 1 second, then it is equal to 1 watt. So it means that if you are applying, uh, you are doing 1 joule of work in 1 second, your rate is like this. So that is having a special name which is called 1 watt. So that's it, students. I hope that you have learned all the concepts. If you have some type of queries, you can ask, please. Take care. Allah Hafiz.